And ratios we probably haven't done since grade 9. So seems like the thing we should do. So overhead projector projects to a screen 5 meters away. So we know that total distance is 5. A student standing in front of the projector entertains his or her classmates by using a 20-centimeter long hand cast shadow of a barking dog on the screen. If the student walks to the screen at a speed of 8.8 meters per second, how fast is the size of the dog shadow decreasing at the instant when the... What? Well, this is the assignment. I was going to give the answers to the assignment. You really shouldn't have stopped me. Oh. All right, there's a shadow pocket one. Okay. A boy, 1.2 meters tall, runs towards the lamp post at a rate of 2.2 meters per second. The light bulb is hanging 4.2 meters off the ground. What is the rate at the end of the shadow moving 2.5 meters per post? Okay, a little off. Perfect. Still ratio question. Okay. So what in variables do I need? So we got y. What does y represent? Okay, what's next? Okay, distance from where? Yeah. And the last thing is, what are we measuring? Length of the shadow. So what's the length of, what variable is the length of the shadow? Okay. And then the total, the next one that we have is the S. The S is total length. Right? So that is X plus Y added together. Make sense? Easy as what? Okay, so what do we know? What rate did it give us? Okay, so what rate is that? Is it dx, dy, dx? Dx, yeah, because it's the distance from the lamppost, and that's the speed you're running towards the lamppost at. So what we do know is we have dx over dt being 2.2. Okay, so part A says that what rate is the end of the shadow moving when he's 2.5 meters from the post? So is that, are we solving for, in part A, are we solving for dx or are we solving for dy? Okay, I want you to read B. At what rate is the length of his shadow changing when he's 2.5 centimeters away from the post? So what does variable y stand for? The shadow length. So that's what we're solving for in B. So we're solving for in A, dx over dt. And part B, we're solving with the shadow, so that would be dy over dt. All right. Okay. So part A. Part A. So what do we know? Nothing. We know nothing. Very, very soft stage. Okay. All right. We do know that x plus y equals s. Right? We do know that. We discussed that x plus y equals the distance of s. We discussed that one already. No. Because they change at different rates, remember? Think about area, volume, those sort of things, they're gonna change at different rates. So we can't assume that the differential will add up to the differential of something else, okay? Okay, so for this one, we need to solve for some information. Now, we do have an actual ratio worked out. We do have an actual ratio. So right here, we have three variables. Nothing about them. There's no information, but I do have a ratio. I have a big triangle. Back to grade 9, similar figures. And I have a small triangle. Right? I have 2. So, in my big triangle, I know that 4.2. Now this one, I guess it really doesn't matter. 4.2. What do we do X or Y? Let's do Y. So 4.2 matches with what in the purple triangle? 1.2. Okay, so this is your big triangle, this is your small triangle. Do you guys remember this from grade 9? No, perfect. So the base of the triangle, what's the base of the big triangle, the green triangle? What distance is that? S. And that correlates to, that matches with a similar to Y in the small triangle. No, none of this is ringing a bell from grade 9? Okay. All right, it was a long time ago, in the lab, far. So I've got 4.2y equals 1.2x. What do you guys want to do? We should probably solve for y. So what's that going to be? No, anybody? I did the ratio to that, and it came out to 2/7s, just a little bit nicer. Okay, so we're going to use this to put it back in this one, in that equation. Sorry, I got a little excited. So we're going to put it back into that equation. So we now know what y is. So we have x plus 2/7s equals s. Any suggestions? Don't you think we should solve for s? Seem like a good idea? We need that in our equation. Anybody? No? Because we need s, because we're solving for the derivative of s. So we need to make this equation equal to s. So what do we got here? If I subtract that, I'm going to have x on this side and 5/7 s on that side. Because that would be 7/7s minus the 2/7s s. I did all that in my head, in my fraction work. Do you need to see those steps? No? All right. So what's s equal to? So s is equal to 7/5 s. All right, so let's derive. You ready? So now that you have the equation, we're going to derive that. We're going to find the derivative of that. So dx, sorry. I'm going to take the derivative of s over d of t, that's this side, and I'm going to take the derivative of 7/5 s in respect to t on this side. So what is ds over dt? What's the derivative of that? 7/5. And what's it multiplied by? Dx over dt, do we know this? 2.2. 3.08 meters per second. What magic? You don't know where any of these numbers came from? None? None? You don't ratios? You got that, right? You don't know how to do basic ratios? I don't know. Well, do you know how this happened? Do you know how we set this up? Similar figures. We talked, maybe it was my grade 12 pretty fast. Similar figures, what do we do with similar figures? If they're similar figures, then their size will increase by the same value, and what do we know about the interior angles? They're all equal, right? So the interior angles are congruent, and the size increases the same scale factor. I know what to do with my grade 10 class. We took like big pictures, and we scale factored them down to smaller pictures, or vice versa. We used the big chart paper, so were you in my class? You were in my class. Okay, so you did something like that. This should be vaguely familiar. So what we were trying to figure out is what's the scale factor. The trouble is that in grade 9, you had 3 numbers, and you were looking for 1. In grade 12 calculus, you have 2 numbers, and we're just rearranging the equation. So we solved for y here. So these sides, if you look at this triangle, are similar, right? They both represent the opposite angle, right? 4.2, 1.1, 1.2, sorry, 4.2, 1.2. So then we looked at the bottom, which has a length of s, and that will correspond with the y side. So we're saying that they all increase by the same rate. And that rate is that 2/7 times by the side length. Okay, that's all we did. And then we just substituted it back into that original equation that we made. X distance plus y distance equals the total distance x. That's all we did. And we differentiated, made it equal to s because one side I needed to solve for t of s or d of t. So I just rearranged it. Then we just did the derivative. Magic. Much easier if I just say magic. Okay, so that was part A. Part B is going to be a little bit easier because we did some of the math already. Okay, part B, switching colors here. Part B says we are going to do dy over dt. So what do we know? Okay. Well, we have something even easier. Right? That's our equation from here. Right? If we differentiate what? Kind of irrelevant. Based on the information that we have, it's irrelevant. Good try though. Good call because we have used it everywhere else. So if I just take this and I differentiate all the parts to it, dx over dt, do we have that one already? dx over dt, do we have that one already? And we are trying to solve for dy over dt. So dx over dt was 3.08. dx over dt is 2.2. So dy over dt is 0.88. So we could have gone the long way. We could have done all of that, but there's really no need to when you have all of it. Let's do